Before we start on notes for the structure of the atom, make sure that you have downloaded and printed a copy of the notes so that you can just fill in the parts that are needed. And so we'll talk about the atom, and a good definition to be used for atoms are that they are the smallest particle of an element that still retains the properties of the element. And atoms are extremely small. They are submicroscopic. If we look at a copper atom, the diameter of that atom is going to be measured in picometers, which is 10 to the minus 10. Atoms cannot be seen with a conventional microscope or the naked eye for that matter, but we can see individual atoms with something called an STM, which stands for a scanning tunneling microscope. And you may remember from back in physical science or one of your middle school sciences that there are two regions of the atom. See if you can remember what they are. We're going to have the nucleus and our particles of mass. The nucleus is the part that has mass, and so the nucleus is contained of protons and neutrons. And as I said, it accounts for most of the atom's mass. It's the dense center of the atom. Then we have an electron cloud, or we're going to describe it as, an electron cloud. Energy levels, we'll talk a little bit more about those later in the semester. That's going to be where our electrons are located, and that's going to account for most of the atom's volume. Atoms are mostly empty space. If an atom were the size of the football stadium, the nucleus would actually be the size of a marble, just to help you kind of put that in perspective a little bit. And so the three parts of the atom, the three particles, the electron, the proton, and the neutron. So the symbol for an electron is usually an E with a little minus as a superscript. We have already said, where's it located? It's located outside of the nucleus. It has a relative charge of -1. That's relative to the other two particles. But compared to the other two particles, it really has no mass, and so it's considered to have a mass of 0. Our proton will be a P with a little plus superscript, and we have said already our protons are located inside the nucleus. Protons are charged positively. The P and the P go together, so relative electric charge of +1, and it will have a mass relative to the other particles of 1. Neutron, we have an N for neutron and then a little 0 as a superscript. Neutron's located in the nucleus, does not have a charge, that's where the little 0 comes from, but it does have mass, so it has a relative mass of 1. The atomic number is the number of protons in an atom. So star this, okay? That's a terrible star that I just made, but it's the number of protons. If we change the number of protons in something, we're going to change the identity of the element. And so protons identify the element. Make sure you make a big note of that. All atoms of the same element have the same number of protons. We can change the number of neutrons. We can even make an ion and change the number of electrons. As long as the protons stay the same, we're still talking about the same element. And in neutral atoms, that means that they don't have a positive or a negative charge. The atomic number, in addition to the number of protons, is also going to equal the number of electrons. And so this is a little block on the periodic table. And so our hydrogen, you'll see you have a symbol here. So this is going to be our symbol. This is going to be the atomic number, which, as we said already, is going to be the number of protons. And then the 1.01 we say is the average atomic mass. And we will talk about why it is a decimal for most elements in another lecture. So, armed with this information, you should be able to complete the Inside the Atom worksheet. A couple examples from that worksheet. The worksheet asks if it's an atom or an ion. Well, in an atom, your protons will equal your electrons, or your electrons will equal your protons. In an ion, you'll either have more electrons, and you will be negatively charged, or you will have more protons than electrons, and you will be positively charged. For example, if we have, let's say we have magnesium, okay? And your atomic number for magnesium is 12, and your mass number, which is your number of protons plus neutrons, or the number of particles that have mass, is 24. So if magnesium has an atomic number of 12, that means it has 12 protons. If it has a mass number of 24, 24 minus 12 is 12, so it must have 12 neutrons, because added together, they will make up our mass. And then it is neutral, and so it will also have, 12 electrons. Sorry about that. ECT, I got a little fat there. Okay. Let's say we have a magnesium 2+ ion. It's magnesium, so it's still going to have 12 protons because that identifies it as magnesium. And it still has a mass of 24, so it's still going to have 12 neutrons, but our electrons are going to be different. So it has a +2 charge. That means there's two more positive particles than there are negative particles. And if our positive particles are our protons, then there must only be 10 electrons if our ion has a 2+ charge. So armed with this information, please complete the Inside the Atom worksheet, and then upload your worksheet to Canvas, and then we'll go over the answers the next time we meet in Teams. If you have any questions, just email me, or